More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at home is right for your child, visit mathnasium.com/at-home. Mathnasium at home, changing lives through math.
Sorry, everybody. I forgot to unmute myself. My name is John. I am the AVP of Education and Training for the system, and I'm really excited to have you here today to talk about the Euclidean algorithm and how we use it for something we call to find greatest common factor. It's an exciting topic and something that you may have already learned in school. If you're a parent, you may have helped your child do their homework on GCF. And it's just an interesting way to look at numbers and help us find the greatest common factor. I have a painting of Euclid. And just to give you a little bit of history, because you might be thinking Euclidean, like, what does that mean? And I guess in the same way that a child would carry around a scooter or a skateboard or something, a lot of the depictions of Euclid have him holding a compass, and you can see him holding a compass. Which is kind of cool. And he's known as the father of geometry. And interestingly enough, his book that's called Elements not only is probably the most widely used textbook in history, it's certainly one of the most widely used books in history, period. And it's kind of cool to think about that everything that you would learn in a geometry class in school actually flows down from about 300 BC from Euclid. So if you're interested in looking in his book of Elements about the topic that we're going to talk about today, what you're going to be looking for is something called Book 7, Proposition 2. So if you want to kind of look up and see how it's worded there, it's really interesting. And then you can connect it to what we talked about today and see if you can make the connection between the way it's written in that book and the way we talk about it today with numbers. And like I said, Euclid's certainly the biggest impact was geometry. And we're going to talk more about something more number theory related today. And some of these Mathnasium Live, Mathnasium Schoolhouse sessions, I want to talk more about his impact on geometry, which will be really, really interesting for us to do. So I'm going to dive into this in the chat box. It would be really awesome if you shared who you are and where you're from, if you're a parent, if you're some of our Mathnasium friends that are doing watch parties and that, really like to know who you are and what brings you here today. So as always, I'd like to start off with just a few things that I would like you to be comfortable with. Hopefully you are. If not, then it might make some of this a little bit tricky, but that's okay. Again, I just want you to work hard, and I want to show you something new and interesting, and then you'll get a chance to practice. So the first thing is, when we learn multiplication, when we learn our facts, a lot of times we learn that we're going to take these things and we're going to put them together. So you might take two numbers and add them together or multiply them. But it's often really important to think about something as I split it apart. So I want you to be comfortable with, instead of starting with 7 times 5, I want to think of 35 as being 7 times 5. I want to think of it the other way. So 35 is 7 times 5. It's a little bit different. A lot of times the question will be, well, what's 7 times 5? I want to think of it in a different way. Okay. Second thing And if you join me on Tuesday, and I hope I have some people joining me again, certainly, we talked a lot about division with remainder. And the concept of remainder, again, in this conversation is going to be really important. So I'm thinking about 50 divided by 6 and that it's 8 remainder 2. Okay, 6, there are 8 6s in 50 with 2 left over. And then I'm going to stretch your brain just a little bit and think about some division facts with remainder that might be outside your normal multiplication facts or the division facts that you know. Okay. So this is an example. It's not too bad. And when you're practicing this, you can practice this and just take a little bit more time with it. You'll have a worksheet that you can do. So just something like this that you just want to be, maybe do some, maybe some long division, or if you come to Mathnasium, we'll teach you some really cool number sense ways to figure this out all in your head. But 120 divided by 9 will be 13 remainder 3. And so just a little bit outside of what you might be totally comfortable with, but that's okay. And then the concept of GCF overall. So if I were to ask you what the GCF or the greatest common factor of 14 and 40, you probably have done this in school, but just so we're all on the same page, the greatest common factor is the largest number that divides into both 14 and 40 evenly, which means that there's no remainder. And there's a lot of ways that you can figure it out. You can figure that out by listing all the factors of 14 and 40 and identifying which is the largest one. You can use your factor trees, what's called a prime factorization. But I'm going to teach you a way to do this in a different way than those two things. And it's really cool. Okay? So if we're good with all of that, let's move on and talk about the lesson. So before we talk about this Euclidean algorithm and what that is, and we'll kind of get into what algorithm means and how we do this, let's take a step and just talk about something that, sorry, write that a little bit cleaner. So if I were to ask you what the factors of 20 are, so if you like to type them in the chat box, that would be awesome. It would help me out a little bit. And a lot of you learn, like the rainbow method. So 1, so then 1 and 20, 2 and 10, 4 and 5, and that's it. Okay. And like I mentioned earlier, you want to think of 20 as 1 times 20. You can think of 20 as being 2 times 10. So you have all those ways that you can think about how you use those factors and those factor pairs, in this case with 20. But I want to do this in just a little bit of a different way. And I'm actually going to ask you to think of 20. And I'm going to choose a number that's not in this list of factors, okay? And if you can do this, and we'll practice it, then you actually can do this entire lesson from start to finish, okay? And I'm gonna choose 3. I'll change it to multiplication, okay? And I'd like you to fill in the blanks for me. Okay. And you can type what would go in the blanks in the chat box. But this is a little bit different. And if you're comfortable with division can help you a lot here. Because I can kind of think of this as how I would answer this question will actually fill in the blanks above. So 3 times some number plus another number is going to give me 20. So I'm going to split up 20 in a way that might be just a little bit different. It might seem strange at first. But thinking about numbers in this way is really important. You want to think about numbers in all different ways. Okay. So I'm thinking about my 3's facts, and I know 3 times 6 is 18, and 3 times 7 is 21. And it's really important to not go past this number here. So 3 times 7 is too big. So I'm going to put a 6 there. And now my question to you is, what number would I put in this blank here so that I make 20? And you can type your answer in. The answer is 2. And then you're just going to take a second and make sure that you're correct and make sure that I'm correct. You can always help me check myself. So the question is 3 times 6 plus 2 equal to 20? And the answer is yes. 3 times 6 is 18, plus 2 more gives me 20. Okay. Let's do another. So let's start with 34. And see if you can help me fill in the blanks here. So 5 times some number plus another number to give me 34. Okay, and we're thinking our 5's facts. 5 times 6 is 30. 5 times 7 is 35, and that's too much. So I'm going to write a 6 here. And how many do I have to add on to 30 to make 34? And that's 4. Okay. Let's do one more together. And we'll stretch this just a little bit further. And if it helps you, remember, I can think of this, the answer to this question with remainder will fill in those 2 blanks for me, okay? So you can think of it as 106 divided by 7. And like I said earlier, if you're a Mathnasium student or you come visit us at Mathnasium, we'll show you all this really cool stuff on how to figure this out without long division. And if you said 106 divided by 7 is 15, remainder 1, you're right. 15 times 7 is 105. Add 1 more to get 106. But these help me because I would put that there, and I would put that there. So as we're going through this, if you need that to help you, that's totally fine. And the more you practice, the faster you'll get. So let's take a look at how to do this to find GCF now, greatest common factor. And I want to find the greatest common factor of 8 and 20. And you may know how to do this already, but I want to show you a different way, okay? And remember, we're trying to find the largest number that divides into both 8 and 20 with no remainder. So the way this works is, and this is called an algorithm, and you'll learn algorithms as you continue to get older, but an algorithm is a process that I'm going to repeat over and over and over again until something important happens. So we might repeat these steps over and over and over again, but eventually we're going to stop, okay? This process will always work and it will always end, okay? So an algorithm is just a way of saying I'm going to do this process over and over and over again. That's the important thing to know here. Okay? And the way this works is I'm going to take the larger of the 2 numbers, in this case it's 20, and I'm going to set it equal to the smaller of the 2 times some number plus another number. In the same way we just did it before. Okay. Sometimes colors help. And that's always going to be my first step here. I'm going to take the larger of the 2 numbers, set it equal to the smaller of the 2 times a number, plus another number. So we're going to start with our 8 facts and get as close to 20 as we can and just not go past it. So hopefully you see 8 times 2 is 16. Sorry, I didn't mean to do it. 8 times 2 is 16. I'm going to add 4 more onto that to make 20. Okay. Now what I'm looking for when I stop doing this is when this remainder is 0, which it's not, which tells me I have to keep going. In this process, this first factor and this remainder are really important because I'm actually going to bring this down here. And I'm going to set that equal to this remainder times a number that I need to find plus another number. And hopefully you see that and you think, oh, cool, well, 4 times 2 is 8. And there's nothing left over, which is true. And a lot of times in math, we don't write things like plus 0, but quite often in math, it's really important to know that plus 0 is there. And it's important here. So like I said, once I get this plus 0, I have 0 remainder, I'm done. I have nothing more to do. And the way you read this is that this first number, which is really important in this factor pair, is my GCF. The greatest common factor of 8 and 20 is 4. So let's practice and let's do another one, okay? Because that might have seemed a little strange, but let's do another one. So the GCF of, let's say, 18 and 27. And if you're comfortable with greatest common factor, you might look at that and think, okay, I kind of know what that is. But sometimes when you're learning something new, if it's a new process, then, sometimes you start off kind of with an easy one to see how the new process works. And that's what I would like to do here. So tell me in the chat box, what is my first step? If you remember back to what we just did. So I'm going to take the larger of the two numbers, so in this case it's 27. I'm going to set it equal to the smaller times a number that I have to find plus another number, which is really the remainder, what's left over. And see if you can fill in the blanks. And you might think 18 and 27, that's kind of hard. Like you don't learn your 18s facts in school, but that's okay. Anything times 1 is itself. And if you can double 18, you get 36, and that's too much. So 18 times 1 would go here. And the question would be, how many do I have to add to 18 to make 27? The answer is 9. And remember that I'm going to keep doing this over and over and over again until this remainder is 0, which it's not. So I'm going to keep going. So what is my next step here? Because I know I'm not done. And you can type it in and help me. So remember that the first number, this first factor is really important. So I'm going to set 18 equal to this remainder, which is also really important. And then I have to fill in the blanks here, right? That's always going to be the thing. There's 2 pieces of information that I still need. Okay. And again, like the previous one, you say, oh, awesome. 18 and 9 are connected. 9 is a factor. 9 times 2 plus 0. And I'm done. That's exactly what I was looking for. And remember, if I do this right, This is my GCF. It's 9. So that's not so bad. And it's kind of cool. It's kind of cool to think of these numbers as, 27 is not just 9 times 3 and, 1 times 27 and all of those things. It's interesting to think about numbers that are a little bit different, in a different way. Okay. I'm going to give you another one and stretch, and I'm going to give you a minute just to think about it. Okay. And actually, it might be helpful if I leave this up here for you. So what if I wanted to find the GCF of 100 and 144? So I want the largest number that divides into 100 and 144 evenly. And you can think that if you were going to write out all of these factors and try to find the biggest one, that's a long process here. It would take a long time to write all the factors of 100 and 144 and find the largest one. Or you can use the prime factorization, and that takes some time too. And this is kind of a way that might be faster. So think about how you would set this up. And you can help each other by typing in the chat box, like, what is the first step? Like, what would you do first? And you can look at the example above if you'd like, if it's helpful. Okay, so let me help you with the first step if you're having a hard time getting started. So GCF of 100 and 144. Okay. So remember, I'm going to take the larger of the two numbers, which is 144. And I'm going to set that equal to the smaller of the two times a number that I need to find, plus another number that I need to find, which is, you can think of it as being the remainder. They have to be equal, both sides. And even though those are bigger numbers, like, okay, that's, again, not too bad because you're thinking about all the multiples of 100 now. And, 100 times 2 is already too big, and we know that. So it's a good start. Remember in this process that these two numbers are really important as I go through this. So I'm going to kind of line everything up. So 100 equals. This seems weird, but not too bad. Oh, sorry. And just fill in the blanks. Because remember, I stop doing this when I have a remainder of 0 and I have a plus 0 there. So multiples of 44, not so bad. 44 doubled is 88. Okay. And the difference between 100 and 88 is 12. So I know if I add another 44, that's going to be too much. So I'm not going to bother with that. And that difference is helpful to me because that's what goes there. And just take a second and ask yourself, is that true? And you can always help check me too. But 44 times 2 is 88. 12 more onto that is 100. So we're in good shape. I'm going to write this way. So 44 equals 12 times some number plus another number. Now we're getting into things that are a little bit friendlier. So that's good. 44 is 12 times 3 plus 8. Okay. These numbers are important. I bring them down. Because remember, we're not going to stop until this is 0. We're not there yet. but it's an algorithm. We keep doing it over and over and over again. And as long as I do the steps right, I will get to 0 eventually. And that's the challenge question on your worksheet, is why do these numbers always get smaller? That's actually a property here, is that those numbers always continue to get smaller, every one of those remainders. It's something to think about. And because they always get smaller, eventually I will hit 0. I could do this 50 times if it takes that many steps. So it will always happen. 12 is equal to 8 times 1 plus 4. And then you think, okay, cool. I get my plus 0 that I want. This is my GCF, and I'm done. So even though I had to do it multiple times, I still got there. And it's a lot of fun. It's a lot of fun to do, I think. So, okay. Let's do another. Make the numbers a little bit smaller. I'm going to give you a moment to set that up and see if you can find it. The greatest common factor of 11 and 45. And I say the same things over and over again. If you're a parent and you're working with your kids, the purposefulness with your language is really important because it helps drive home what it is that you're doing. So I'm going to set the larger equal to the smaller times a number plus another number. Again, we'll think of it as the remainder. Okay. 11 and 45 is not too bad because the 11 facts are pretty accessible. 11 times 4 is 44 plus one more. And what's going to happen here is kind of weird, and it's the reason why I did this one. So you just have to know sometimes weird stuff happens and how you deal with it. So remember, this is a really important number here. I'm going to bring it down. I have 11 equals. This is an important number too. It's your remainder from that step. And you can type in and help me out with what I would fill the blanks in there with. But even though it's kind of weird, it's actually not that bad, right? 11 is equal to 1 times 11 plus 0. Remember, we're all excited because we got the 0 that we wanted, so that's good. And remember that this number here represents your GCF of these two. Okay? And that's 1. So does anybody know when the GCF of two numbers is equal to 1, what we call that? You can type it in. And if you're thinking to yourself, they're relatively prime, you're right. That's when that happens, they're said to be relatively prime. Okay? So there's a little cool term if you hadn't learned that. All right. One last thing here I wanted to show you that's kind of cool. It actually is the same process, but it's visual. And some of you understand things better visually using pictures than maybe some of the stuff that we talked about. But I hope you understand it both ways. Now, I have here on my screen, it's on your screen too, I have here a 20 by 12 rectangle. So I want to find the greatest common factor of 12 and 20, and now you have a lot of different ways that you can do it, and I hope you practice the way you learned today. But I want to show you a different way to think of it, which is kind of cool. And if you're a parent or if you want to ask for some grid paper, the grid paper is very helpful here to help you see what happens next. But I want to find the largest number that divides into both 12 and 20 evenly. Like I said, there are other ways to find it. If you're really good with GCF, you might already be thinking, what the answer is, but this is a visual way to think of the same thing. And what I'm going to do is I'm actually going to start breaking this rectangle up into squares. Okay. So what I've created there is a 12 by 12 square. Okay. So this is 12, and so is that. Okay. And I know that we've done a lesson previously on composite area and just thinking about how we break up shapes into smaller shapes and things like that. So my question to you would be is if it is 12 from here to here, and this entire length is 20, then what is this length here from here to here? Okay. So this should be 8. And what I want to do now is I want to create another square, but I'm going to create an 8 by 8 square in this empty space right up here. Because this is, I've already removed that, or I've already kind of taken it out of this problem, right? So I'm going to now draw an 8 by 8 square here. Okay. And you can't see it, but I have a ruler helping me draw this. Okay. So there's an 8 by 8 square. I'm going to take that out too. Okay. I'm trying to fill up this rectangle all the way. And I'm going to show you how this is connected to GCF and what we just learned in a moment. Okay. So now my question to you is, if this was from this red X to this red X is 12, and from here to here is 8, then what is this length from here to here? So the entire thing was 12. This is 8. How much is left over? And it's 4. Right? And how far is it from here to here? We know it's 8 because it's 8 from here to here. So this is also 8 from here to here, which means that I can draw 2 4 by 4 squares right in here, which is really cool. Now I've successfully filled in that entire original rectangle using smaller squares. Now, you might be asking, how does that connect to the original problem? And I'm going to show you using the algorithm step by step. So remember, I'm going to go through this kind of quickly. The larger was equal to the smaller times some number, and I'm just going to go ahead and fill that in for you. But think about what I did. My first square that I drew was 12 by 12. This was the first square that I drew, was 12 by 12. I'm going to repeat the process. 12 is equal to 8 times 1 plus 4. We'll over the dimensions of the second square that I drew. Remember, it was 8 by 8. It was the green one there. 8 by 8. Apply this algorithm again, and I get 4 times 2 plus 0. Okay, so now connect it. Remember that the last squares that I drew were 4 by 4. And when I drew those 4 by 4 squares in, I was done. The process that I did visually here for you and the algorithm are the exact same. It's just the visual of what it is that I did. And you can practice that too, which is kind of cool. And do them both at the same time and see if you can figure it out. But once I get that remainder 0, whatever this number is, the dimensions are the dimensions of the last square that I drew to fill in that original rectangle. And with that, I think we're done for today. So I really appreciate all of you and all of the responses that I've gotten. I hope you learned something interesting and new. Look for the practice worksheets so that you can practice this. And like I said, I think you all will get it and think that it's a very cool way to look at greatest common factor and show as many people as you can, because you really learn something when you show it to someone else. I really appreciate all of you joining us. We are here every day, and I hope you enjoy what it is that you've been learning on the Mathnasium Schoolhouse. I will see you next week. Bye now.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.